in about 2020, I think, thereabouts, a bunch of people in Denmark in the built environment industry, some architectural practices and engineers got together to say, let's actually do the numbers on buildings. If we have signed up to the Paris Agreement, which we have, like most countries have, but we all know that we've had difficulty actually getting traction on it, as in emissions continue to go up. In fact, we have more coal burn last year than ever before globally. And we're burning past 1.5 in the club, on our way to 2.7 or thereabouts. So nonetheless, the Paris Agreement is what we have. If you look at that, then you could then say, okay, what does limiting emissions mean? Well, it gives you an emissions budget. This is what the Danes calculated back in 2020. We've got an emissions budget that we need to live within that would keep us at a safe level, a safe operating space for humanity.
Amen.
So there's lots of academic work behind all of those numbers, but you end up with this idea of a budget for the globe, and then you can figure out, well, what's a budget then for a country like Denmark? Let's just pro-rata it down based on its population. And then within that, what's a reasonable budget then for the built environment sector, based roughly on the proportion that currently we use this, if you like, of a country's budget. So you get a number, and you can then calculate that, okay, within that, then what's a typical building? And then what's the typical building need to get to stay within this safe operating space? So again, it's very, very simple in a way. You know, we always talk about, quite often conservative politicians say, you know, running the economy is like running a household. You have a budget, you need to live within it. Which always annoys me, but anyway. Using that same example, you've got an emissions budget to work with. It actually changes everything, because you realize that we don't think like that, actually. We just assume that we can set targets for things like building or cars or whatever.
Yeah.
And it's as if there is no sort of finite set of materials on the planet, and of course there is.
Yeah.
So the Danes figured out all of this and figured out, therefore, their built environment sector needs to go from this down to about this huge drop, like an almost 90% drop in their case. And so they said, let's set over the idea of a cascading set of emissions within that. Here's where we are now. Here's where we need to get to in about 9-10 years, based on 2020. And if we can do that, using that budget carefully, we can get to a point where we could get the built environment industry working within a safe operating space. But don't be under any illusion. This is like a 90% drop ultimately. But we can go down to like 10% a year, 9% a year.
Yeah.
So, and they managed to get that into the regulations one way or another, because they led an industry-wide movement then. They got about 500 to 600 different organizations signed up. Architects, municipalities, property developers, investment funds, things like that. And that placed sufficient pressure on the government to say, okay, the industry seems to be looking for this, then we should probably honor that and do something about it. That's incredibly important right there, because there's always exemplars and small prototypes and things like this that, you know, could show, yes, we can build within, let's say, 6 or 7 kilograms of emissions per square meter. But most building is unchanged.
Well,
there's nothing forcing it not to.
Yeah.
It's not equitable at all in that sense. So you have innovators who have to take a huge amount of personal risk. You'll know them in Melbourne, which ones those are, that have almost gone out of business trying to make sustainable buildings happen. With no support from government, in fact, quite the opposite. And yet, despite those great innovators, the system itself doesn't change. So you still see incredibly bad quality urban development left, right, and centre, almost like Victoria Forest Trolley. So a legal change, actually my colleague Mariana Mazzucato would say, tilts the playing field in the right direction. Doesn't just level the playing field, tilts it, as in it tilts it towards, in this case, working towards the Paris Agreement.
But let's just start with some of those numbers. You mentioned between 6 and 7 kilograms per square meter. Let's give us the number of today's Australian home.
461.8 kilograms of CO2e, which is the CO2 equivalent of greenhouse gases, basically. So kilograms of greenhouse gas, imagine that as a volume, if you like. Per square meter. So 461 is your average Australian house, or home, actually. Now that's taking into account apartments, townhouses, whacking grade, single stories, detached things as well. That's an average based on numbers run in our lab here. 461 then needs to come down to 6.6. So that's a 98% drop in emissions per square meter ongoing as soon as possible. Now, one thing to just bear in mind as well, when the Paris Agreement was announced, we've sort of forgotten this, but 1.5 degrees was not a good thing. It was framed as a disaster. And we've kind of forgotten that because we've blown past it, and we know it, this is what humans do.
Yeah.
Psychologically, as we know, it's like, well, okay, that was then. If only I'd have gone to the dentist back then, I wouldn't be having root canal now. But still, 1.5 was framed as a disaster. 2 will be a disaster for lots of countries and people in the world. 2.7, which is what we're aiming towards, really off the charts. So we can spread out this emissions budget over time and then, look at progressive improvements step by step towards that target of 6.6. But that's, as you say, rolling the dice in more and more adventurous ways. So we've looked at, well, what if we didn't build as much? What would that mean? We've still got this emissions budget, if you like, to work with for buildings. We don't build as much, we can build more carefully, or we can increase the budget per square meter within those buildings if you wanted to. What if we made smaller buildings? Because size is already relevant in Australia. We build the biggest houses on average in the world. This is a single story detached house. It's about 240 square meters, which is enormous. Which tells us actually that these space increases are not driven by actual housing demand, as in numbers of people. They're driven by financialization, if you like, market logics, as in
Changing markets.
Yeah, if you put an extra room in your house, it is more saleable. So you're building a financial asset there, not really a place to live in, not a home.
In a way, what you're doing is taking a huge amount of complexity and trying to tell a story that ends up with a kind of blunt instrument.
Yeah, very blunt number.
And I think it could be said that one of the less useful aspects of the way climate is discussed quite often is that it is so layered and complex, that it leads to a point of where you don't know where the agency is. And all of a sudden, because you can't quite yet get to a electric car and you've still got a gas car, you're thinking, well, I'm just driving a car, so I might as well just kind of give up. There's a kind of how do you turn these ideas into action? As Kate Heo says, the gap is not so much between those who believe there's climate change and those who don't believe there's climate change. It's between those who are lost in a quandary of pessimism and those who are deciding to do something about it. What's important about this seems to be that it's, you described it as a MacGuffin. It's almost like it's not even important to some extent. It's not about whether it's 98 or 87 it's large. And there's only one way to try and do this, which is to bring that line down. And so I think that's an important thing. I presume you were very conscious of the need to bring it down to a single one line kind of,
Yeah, and there's visualizations of that which help as well, as in here's a big column in a bar chart, here's a much smaller, 98%, here's a load of houses, here's probably a number of houses we can actually make. In particular, I've come to housing because of this sort of sense that the housing crisis just sits next door to the climate crisis, but they don't really intersect somehow in policymakers' heads or politicians' heads, possibly even the average punter's head. They say, well, the housing crisis is over here, that's really important, and it is obviously people to have a home. And we are then going to announce a set of policy measures about that, like 200,000 rooms a year for the next 5 to 6 years. Meanwhile, the climate crisis is over here saying we need to be a net zero country, or we need to pull our emissions down by this. And it's as if these two things can coexist without them ever talking to each other.
Not only not talking to each other, but actually being in tension with each other.
Well, that's the thing. Both of those are pointing at exactly the same materials, and that's the point we're trying to make. So if you build those houses out of concrete, steel, and brick, which is entirely like it, and that makes the climate crisis 10 times worse. Or rather, what we work out is, if you build the housing targets in Australia, those 200,000 homes a year, which government said is the goal, that uses 200% of the Australia's total carbon budget for everything. So there's no carbon left for fishing, football, going to the shops, whatever, gardening, whatever you might do, clothes, industry, nothing. So what we're saying is that has to be the same policy. You can't have some separate. We need to look at sustainable or climate-oriented housing, but socially just, all at the same time. It's the same thing. It's not a separate thing. So yeah, the number is ultimately not relevant, because what is relevant is action, and your good question then starts triggering thoughts. Well, how do you motivate action? Or what does that look like? We're just using the number in a way to get attention and just like, this gives us a sense of the scale of change required. Just how much change we're talking about. Just so if anybody's not sure about that, and they think that we can just transition our way elegantly towards it. This is not the existing industry just trying harder. It's pointing out actually the inconsistencies within our current policy settings. We've got the Paris Agreement that we've signed up to, and the many other things. And yet our construction code does not ask people to think that hard about embodied carbon and material at all.
Not at all, no.
If we go back to buildings, most buildings about 150 years ago would have been built with biomaterial, as we now call it. Yeah. So you're only really thinking about, let's say, concrete coming in as a major building material from the 1920s, 30s onwards. That's only 100 years. So it's not that long. It's generations.
Apart from Rome, but yes, okay.
Yes, no, they would have done it probably in a less carbon-intensive way as well, ironically. So a lot of this stuff is actually, majority of building for all time has been built in ways which are not that carbon-intensive.
Yes.
So I just want to sort of make that point, that actually some of the most interesting work going on, folk that are into rammed earth and bamboo and straw and insulation and bringing the thatch and so on and so on.
Which excites you the most in terms of like, whoa, that's really got...
I think hempcrete does a lot of stuff that concrete does, and is a great crop to grow from a kind of crop point of view. Very useful farmers like in terms of having and regenerating their soil. It's pretty malleable in the same way that concrete can be, at least block form. Timber, star, if you like. Because that can do everything from very, very small, simple structures all the way through to mass timber, quite complex manufacturing stuff. That means, of course, we need to think about that whole thing very carefully indeed in terms of reforesting. And
land use and
biodiversity. All those things. I mean, very interesting, because again, when you keep pulling the thread on these things, then you get to, again, you realize we've been deforesting a lot. Why is that? Well, we've been using that land instead into agriculture for food or for urban development. And then you look at, well, do we need as much land being used for agriculture for food? Actually, very good question. There's most of that in the world is to do with meat production. And you realize that actually, well, maybe, so the answer to sustainable buildings is maybe eating a little less meat.
We generally use the approach that what we're doing is sustainable. You can continue to do it for the next 50 years. You're improving your soils. You're using less inputs for your crops, so it's better for the environment. And your crop health and the produce that you're producing is more nutrient dense off the back of it.
Right, okay. Tell me about what was happening on the soil, like in the 10 years or whatever leading up to it. Were you seeing the soil getting depleted? Were you seeing that in the yields, or what was the status of the yields over the previous years?
Potatoes is a very good kind of, like a case study crop
indicator,
for this.
right? Yeah,
because they go under the ground.
So
you come in with a potato harvester, you dig the ground up, you lift all your soil. When you're sitting on that seat, you can see everything, and then you need very, very good soil structure, soil aggregation. Otherwise, the dirt will just cake onto the potatoes.
Right.
And then no market will take them.
Right, okay.
So when you're doing adverse things on the farm, any little error you make, it shows up great at harvest.
Right.
So in a big way.
Okay, right. Okay.
And then what we learn is the conventional, your traditional kind of practice, you cultivate your ground, you go and you spray the shit out of it, and then you put all your synthetic fertilizers down, and over time this has led to our soil, in essence, become stupid. Like you've killed all the biology in the ground because they can't cohabitate with synthetic fertilizers.
So you decided to move away, or not move away, but in addition to your cropping, to go down the route of hemp. Let's talk a little bit about hemp and why we're here, in fact. What are some of the qualities of hemp that bring soil health back?
Yeah, so originally we went to hemp as a cover crop because we thought, when we were pretty naive to this whole regenerative ag thing, we thought, we'll do this, it'll cover the ground, and maybe we can harvest a seed crop off it. We'll see how that goes. It kind of wasn't economical. Like hemp's, to grow it, you got to get licenses from the DPI, and it was a bit involved. So we went and did all that, and we're halfway down the road, and we thought, righto, how can we kind of make this work? Because the first crop we grew, the next potato crop after, the soil was shit. It had completely changed. And like to grow one crop and see the difference in the ground was unheard of.
The soil had completely changed between one crop and the next crop.
Yeah.
Wow.
Like again with the potatoes, you go in and every time you check them up, you walk into the field, you dig the hill, check how many potatoes are under there. Normally, like a traditional growing season in Hillston, the ground will set hard, gets a good crusting layer on it, and you kind of got to bust it open with your hands to even be able to dig the spuds out. And
Yeah, right.
You walk in there after a hemp crop, and it's just friable. Soil was aggregated. You could just dig the hill out. The spuds came out easy,
Wow.
and they look good.
Yeah.
Real good.
Yeah, right. Why does can you talk a little around when you don't use hemp and you said you dig it up, it's really hard. Can you talk a little bit about what causes that compaction? Why does the soil get in a bad way in that way?
So, yeah, it's not so normal. Like we run center point irrigation.
Yep.
And then there's a few things that lead to compaction in your ground. It's like you're running heavy harvesters over it, tractors over it, you're always cultivating, watering, like a lot of water also compacts your soil. And then it helps it like you'll find we work our soil to about 300 mil, sometimes 450. And you'll find if you dig down to 450 to the where you work it to, it's still like a rock under there. Like there's a compaction layer that's about 300 mil.
Wow.
Traditionally, your roots of your potato crops will go down to about that 450 where you rip to, and that's when they'll stall out. So that's kind of where everything was kept. Unless you go in and then you deep rip it to 600. But wherever you go to, that's where your compaction layer is going to be.
Right. And that's bad. Why? What happens with it?
Oh, it's like a plant. So your nutrients will leach through your soil profile. Some soils more readily than others, but eventually they get down and they can leach through that compaction layer, but your plant roots, and the water's through that compaction layer, but your plant roots can't get down there to access it. So we've had to, it's kind of like off this hemp, one of the biggest things it has is a taproot, like a real hard foraging taproot. And like we've dug test pits that go down 2 meters deep. And
The taproot goes down 2 meters.
yeah, we dug at least 2 meters, and you can still trace the taproot through the wall all the way down to the bottom of the hole. It's just got sick of digging.
And presumably then once you crop it, what happens to the taproot? Does it just kind of shrink and then does that create little straws down into the ground? Is that what happens?
Yeah, exactly. So when you harvest hemp, like we come along and you're taking the biomass on top of the field, which is about like they go 5-6 meters tall.
6 meters tall.
Yeah.
Right. 2-story building.
Yeah. It's an incredible crop. You don't believe it when you're watching it. Like we had crops growing 10 centimeters every day for 3 weeks straight. I think after our first crops and the benefits we saw, what it did to the soil, we thought we're going to have to find a way we can commercialise this crop.
The old man said, yeah, maybe you're right. We'll give it a go for a couple of years.
Yeah. No, and it was everywhere we grew hemp on our farm over 2 years. It was night and day, the difference it was doing to the soil.
Right. Okay.
So then we thought, what can we do? We can't really sell the seed because for us there wasn't enough money in it. So we started exploring this industrial hemp path. So let's make building materials out of it. So where that kind of led us, very young industry in Australia, and there wasn't really many people doing it. And the people we kind of ran into along the lines that could build the products, a bit like what we're doing today. They needed the hemp decorticated. So you have to remove the fibre, and then we call the wood chips are essentially hurd. So the hurd is essentially wood chips, and then you need a system which we call...
Hang on a second. You got them over here.
Yeah.
What you're talking about. This is the herd here.
That there's your wood chip. So yeah, it's the core of the plant.
And the machine, this facility, you called it, is it a decorticator?
Yeah, decortication.
Okay,
facility,
right.
yeah.
Okay, so you had to make one, buy one, get one?
Yeah.
Yeah.
When we were pretty green. Hindsight's a beautiful thing, but we thought it wasn't going to be as hard as it was. When we started, we were on our own.
Yeah.
And we had a bale of hemp, because when we cut it down, we mow it, windrow it, rake it, and then put a bale over it. So
Yeah.
we ended up with 1,000 bales of hemp. Like, we got to do something with this.
We ended up with 1,000. You go,
Yeah.
what happens next?
Yeah, so essentially we went to America.
Yeah.
No, my father did.
Yeah.
And then he found some guys over there in Texas that were playing around with it. Got one piece of machinery out of the States, and then that didn't work. And then we started building our own machines that could kind of handle it. And it took us about 2 years.
It's a journey, eh?
Yeah, we were playing around until we kind of, 2 years and about 20 years off your life. until we finally found we could get a product, we could get it to run, the machines wouldn't stall out, and then we were putting hurd out that side of the machine, and we're putting fibre out that side of the machine.
So you've got this crop. What's your projections? What are you hoping to be able to do with the herd?
Oh, I think, like I said, from a carbon perspective, just solely, if you look at that, like, you got a product here that they say for every 1 tonne of biomass, which is the stuff above the ground, you get 1.2 tonnes of CO2 carbon stored.
Right, okay.
Like just of gas you're putting into the plant, and that. So yeah, a bit more to go down the road on that, but
Yep.
you can compound the crop with, like, that's just what's happening above ground. What's happening underground, and this is why we're seeing so much benefit from the farming perspective, is the amount of carbon it's putting into the soil. It's unbelievable. And essentially in your ground, and this is tying it back into the regenerative farming model, the ability of the hemp plant to pull carbon out of the atmosphere and put it back into the ground, and this is what biology feeds on, carbon. It's like, there's no other crop that like even can come close to what it does. And that's why we're seeing such good benefits in our other crops,
Yeah.
purely from that process. Like we had some neighbours of ours grew some last summer, 2 summers ago.
Yeah.
And then they've just planted a cotton crop behind it this year, and like it's their best yielding cotton paddock.
Is that right?
Yeah.
And they did that as a case study just to see what would happen between the two.
Yeah, they kind of grew some hemp on this model that we were kind of putting together.
Yeah.
And then, they can't believe it. And that's purely just from the combination of it all, like the carbon, the microbiology is being fed, it's multiplying up, that soil compaction layers, the taproot's broken through that, the nutrients, sub-nutrients that are down into the soil, the cotton's been able to get down there. Did it use a bit more water? Yes, because the water can go through the profile a bit more.
Yeah.
But it's all adding, like in agriculture, that's what we want. We want good soil infiltration. We want good nutrient cycling.
Yeah.
And all the rest. And
That's great. So now we're at Eagle Masonry, and we're doing a bit of a test today. Do you want to describe a little bit? There's guys in there that probably know what they're doing better than you or I.
Yeah, 100%.
But just broadly, what's the plan today?
so we've brought some of our hemp herd that we've grown and decorticated in Hilton up here to run a trial on the bricks to make bricks, and basically we'll put our herd as, I'm not sure on the percentages, and then hopefully we can pump a brick out, and if that works and it's the first of its testing, then this whole model will start to grow legs. We can grow more hemp.
So they prep up, it's like, it's like that up, oh, it's the free where it's up to make by the scenes. So with the stuff. Except we set up the also this is 20 get up.
So normally they use a big feeder when they're using concrete, but today, because it's a small load, just a small batch, they're manually loading it. And what depends on today, because they have to get the mix just right so that it holds together properly when it comes out of the load. And then they'll also test to see how long it takes for that thing to cure, because time is important. If it takes 5 days to cure or 25 days to cure, it could make all the difference to whether it's a commercially viable or not. But this is the moment of truth to see whether this hemp-free blocks can work or not.
Music down, Ringo.
I reckon you need Peterson like that.
Look at the wobble on it. Looks like Mum's cooking cookies.
Dissolving and potentially set like a quicker set. That's chicken. What do you stop? Because it's an animal.
My dad had a younger sister in New Zealand, so they went there for holidays, and Mum and Dad came back with a book of an architect called Hundertwasser, and all of his buildings had green roofs, and I just went. And and I started dreaming about building my own house. Not had no intention of being an architect or a builder. I just had real interest in it. And then I would have been maybe a year later, 15. The family business was going really well. And they commissioned a 10,000 square metre glass house with a boiler room and computer systems and curtains, and the whole thing was, fully automated. And the containers started to arrive from the Netherlands. And at the same time, my mum and dad were doing a renovation of a bathroom and adding a bedroom. Mm-hmm. That seemed to take a year. And there was always a mountain of shit in front of our house. Broken tiles, offcuts of...
Yeah, all the waste.
And this Dutch company came in and they didn't have a bin on site. There was no bin. They built 10,000 square metres of the most complex architecture with operable roofs and curtains and irrigation, and there was no bin. There was no offcuts. Everything was designed. And I went, this is crazy. Why are we building? Why are we sending materials to a building job and then the builder has to cut up and a third of it goes into a skip or more sometimes?
Yeah.
So, that really resonated with me, I suppose. I was 13, 14, 15 and just was observing. My main passion was always flowers and growing flowers. And I was growing flowers when I started growing my own flowers when I was maybe 10 or 11. My brothers built a little igloo for me and I started growing freesias and tulips and taking cuttings, and
wow,
I loved it. And that was going to be my life. Because I had no formal training and I was, my obsession with waste, the vessels were all made from waste, electrical cords or whatever.
Right.
And so then I got a really good, that just took off. So my flower career was going well, and so Jenny and I was struggling to get, flower growers grow everything the same size. It's all about uniformity and the monotony, really.
Yeah.
And I wanted the weird, tall, crazy stuff. So we decided to buy a farm and I started planting it out with thousands of different varieties, and that's how it started. And then I wanted to build my own house. And I was quite hanging out a lot with Nonda Katsoulides at the time, and he gave me a lot of confidence really to design my own place, and he made me believe that the way that I wanted to build it was, there's nothing wrong with doing it the way that I wanted to build it, but no one had ever done it like that before.
Yeah.
And so I built my own straw bale house, and the idea was to build that and then just go back to creating art and doing installations. And then, Earl Carter, my friend Earl Carter, photographed it, and Anne-Marie Kiley did a story on it in Vogue, and then it got on the cover. Yeah. And then it just went.
Because everyone's first home was on Vogue. No.
I was like, well, I couldn't believe it. And then, getting emails from Milan and New York and, and I'm like, I'm not even an architect, And then Rob had it. Thing around.
So let's look at some of the things in this building that has been innovative. So let's look at some of the materials. Walk me through almost a kind of a. Do you have in your mind a kind of a pyramid of what's most important, what's slightly less important through that? Like, what are your priorities?
Every time you build a building, you take away an opportunity for that land to be habitat. That for me is the biggest thing. Mm-hmm. So why don't we make sure that when we build a building, we actually allow habitat to thrive? And this is an example of that. Like the species, some of the species on the roof have been extinct in this area for 35, 40 years because rabbits have just decimated these particular grasses, and as a result, the butterflies, the indigenous butterflies that relied on those species are gone because they don't go and visit a new plant. They've spent a long time collaborating with that single species, and now it's gone. So it means they're gone. And so I see the potential of habitat creating buildings as massive. Mm-hmm. So that's one thing, the green roof. So we've got a diversity of species that's all native, apart from the half dozen weeds I just pulled out. And the other thing is the roof is completely flat. And people think I'm crazy, but that again is because when the rain falls, I want to hold on to it. So it's like a battery. I want it to be like a bank. And so the downpipe sits 50 mil above the roof. So it's basically like a water tank. But that means that roof never dries out because it's always got access to water.
Right.
And the insulative effect of that, you don't get any heat gain in summer, you don't get any heat loss in winter from inside. And so for me, the fact that a building can be habitat is probably the one, and actually think that a building can be more biodiverse than what existed before. Because if you look at the plants here in January, it was really dry. In February, the plants here struggle. But because of the rain that fell before Christmas, the plants could still access the water up there. And so you had this situation where everything was dead.
Same plants up there as down here.
And the building, when they did put one of those bloody, what do you call them? Drone up. Mm-hmm. The guys are ringing going, you're not going to believe it. Like, the building is completely green and everything is dead.
Right.
And it's not because we're irrigating it, it's because we've got that simple idea of you're storing it.
Yeah. But then you've got other things as well. You've used a lot of Durapanel.
Yeah, I'm obsessed with straw,
Used to be called Stramit, made by straw. And so that's got amazing thermal qualities. It's reusing what is otherwise a waste product, yeah?
It is the most wasted material on the planet.
Straw?
Yep. There's nothing that comes close.
Right.
You can think about all the plastic and food waste, nothing. There's 500 million farmers that produce straw. And in a place like Bali, they grow 2.5 crops a year. So they don't just grow it like here we might grow wheat and we've got straw once.
Yes.
In Bali, they've got it 2.5 times because they can plant 2 or 3 crops a year, because of the climate. And sadly, still most is burned. And in a place like California, where I just was, I went to an MDF factory there that is trying to make MDF out of straw. They banned the burning of straw stubble in 1994. And so they now flood the field, which means that it now turns to methane.
Oh, jeez.
And so the rice growers
it's a methane manufacturing machine then, yeah?
Yeah.
Yeah, right.
So the rice growers are now responsible for 5% of all of California's emissions.
Wow.
So, and again, why aren't we using it in our buildings?
So they've got a factory now that can turn that straw into the equivalent of what we call MDF.
Yeah, particle board MDF, and 300,000 tons of material they can make per year. But it only uses 5% of the straw that's being generated in the valley.
Jeez, okay.
And when you look at this plant, it is like the machine that makes it is 200 meters long.
Yeah.
Now you're talking about huge volumes.
And presumably here at Durapanel have pretty big machines. And presumably it's using local straw, isn't it?
Yeah.
Right, okay.
I mean, most of it comes from within 100 kilometers. I mean, it makes sense, right? You don't want to get straw.
Yes.
And there's plenty of it, so
they just got supply arrangements with farmers, and it's a way for them to use their waste product, well, what was once a waste product, as a new building material, yeah?
Yeah, no, I've introduced a lot of builders to it over the years, and I remember in 2022, a builder called me who's been using it for about 8 years, and he goes, it's the only building product that didn't go up in price.
Is that right? Wow.
And that made sense, right? Because the farmers, they weren't charging more because it's a waste product. and their costs didn't really change. It was all
Yeah.
local manufacturing, and
Yeah.
so to me that's just a no-brainer. So straw, it's there's a lot of straw in this building. There's a double skin. We've got insulation that's made in my mum's house. I used hemp,
Hemp. Yeah.
but I
You got a
didn't.
bit of hemp in here in the kitchen units.
There's lots of hemp in this building, but not as insulation. And I
Right.
just didn't feel it was right to bring in insulation from the UK
Yeah.
when we're making, we've got an oversupply of glass, and there's some really good insulation being made here from recycled glass.
Right.
So that's here. But then all the desks, all the joinery, all the sliding doors, they're all made from hemp that was grown in Hillston, New South Wales. And yeah, I'm really proud of that.
Yeah. So here's a tricky question, though. I mean, obviously, this school is a private school. In terms of cost, how do you have an order in which, a degree to which this might be more expensive or not more expensive than a standard state school? Where do you
Well, we
think
had
it
the
sits?
state education minister here,
Yeah.
and when we talked about how much it cost per square metre,
Yeah.
this would be the cheapest public school built in the last 2 years. Now,
Really?
how insane is that?
No, you're not serious, really?
I'm serious. Yes, it came to just under $8,000 a square metre. At the moment, public schools are getting built for between $8,000 and $10,000 a square metre.
Wow.
And
Wow.
that just, it
Okay.
actually made me angry, because I thought we've got batteries, we've got solar,
You get so
we've
much.
got,
Yeah. The operational cost of this will be a fraction, presumably, of a state school.
well, it's designed to run, we've designed it for 120%. So there will be days, and because the school has this long-term plan to go, to have a centralised energy grid,
Yeah.
we are connected to the mains power. But I mean, the very first day it was 40 degrees, and we were still sending power back into the grid. And that was a
Really?
real test, because all the air conditioners were running, but yeah, the solar systems worked really well, the batteries worked well, and it was so well insulated that
Yeah.
But it actually, that, I should have been proud, but I wasn't proud. I was actually just annoyed.
Yeah.
Because, my youngest, Rennie, goes to a state school, and the design is shocking, and, it was an $11 million extension, and
Yeah.
I just thought, that's just not right. Why are these poorly operating and functioning buildings and poorly designed buildings not?
So, what would your answer to that? I mean, to the best you understand, why do you think that state is electing to build less effective, less efficient, less comfortable, less healthy buildings and pay more for that?
Well, Frank, one of the main reasons Frank believes it was so economical to build was because I've really thought about the buildability of the building.
Mm-hmm.
And, we had 12 different builders that wanted to build this building,
Mm-hmm.
and they all came up to Mums and saw Mums being built, so they could see how it was bolted together. The whole thing is designed to not have any waste. So the trusses that hold the soil in the roof are 600 deep, or they're actually 595, so they're half a Durapanel. So, everything is designed around not having waste, and that has a big impact, and it's quick build. Even the builders, they said, we thought we would get it built quickly, but we didn't think it would go up as quickly as what it has, and it's really just because the system is,
Okay. So it's a design system.
it's the system, and it goes back to that glass house.
Yeah.
That glass house went up so quick in 6 weeks. 1 hectare of glass was,
Yeah.
they kept telling my dad and my brothers, you'll be able to plant lilies here in 6 weeks, and we just thought, you're out of, like, we've got a fucking bathroom that's taken a year to, you know what I mean?
Because they are risk professionals, the insurance sector and the reinsurance sector have been sounding the clarion call on climate risk for at least 10 years. So particularly big reinsurance companies like Munich Re and Swiss Re, but also big global insurers like AXA have been, signaling this for at least 10 years. They release reports and opinion and things like that. Most recently, in the last 12 months, 2 years, you see them putting a lot of material out there saying, we need to be aware of this.
Are there different geographical areas that rate differently, let's say, in terms of the level of risk in terms of and under insurability? So obviously thinking about the distinction between, say, climate impacts through bushfire or climate impacts through storm flooding or sea level rise. Is there a kind of a ranking, let's say, of climate impacted geographies, like which is potentially the worst?
Yeah, and I mean, I'd need to look the figures up to be very precise with you, and I can do that if you'd like. But the Climate Council just released a report in the last month to 2 months showing the 10 most impacted, climate impacted areas. They'd worked with XDI, which is a climate valuation service, to look at the 10 most climate impacted areas in Australia. And a big swathe of those pretty much run from the Queensland, New South Wales border up to the Central Coast. So we're seeing coastal New South Wales. We're seeing, I mean, Queensland is a highly climate impacted places that are riverine. So it seems to me that most of it, in Australia at least, is looking at flood. So I think we're definitely seeing that, but we're not necessarily seeing it sold as sea level rise. We're seeing it sold as, increased flood risk. And there have been updating of a lot of the flood maps recently around Australia showing most places are significantly more at risk of flood than they had maybe initially assumed they were.
In terms of houses across Australia that either currently or are at risk of being uninsurable, what's the kind of the current status of that across the country, do you think?
The Actuaries Institute report in 2022 showed 10% of Australian households were at extreme insurance affordability stress. They define that well, and I think that's very helpful for us as a measure because they define it as 4 weeks or more of pre-tax income. Now, that's good because 40,000 may be nothing to a wealthy person like you, but a lot to somebody, and 3,000 may be a lot to somebody else. But when you think about it as what's the amount of income that comes into your household, across your whole household before tax, and say, okay, 4 weeks of that, 1/12, has to go to buy a premium. And of course, I buy that premium from my post-tax income. I think most of us would go, oh, well, I couldn't afford that. So once we put it like that, that's a useful measure because what does extreme stress mean? 10% in 2022, 12% in 2023. Their 2024 report showed 15%. We haven't seen their 2025 update yet. But the Climate Council report that came out about 2 months ago, and I found this useful as triangulation, showed something similar, slightly different way of calculating, but about 4.5%, could be 4.4, but around 4.5 are extremely high risk of uninsurability and about unaffordability, and another 10 or a little bit more than that percent at moderately high uninsurability. So still coming up with around that 15%. So I think if we're getting two different measures coming up with that, we could say, yeah, around 15% of households, it's unaffordable. And that probably means a few more than that in reality will be underinsured or only insured for certain things.
I presume that then has ripple on effects economically, such as banks or lenders kind of retreating from high risk areas. Are you seeing that happening, like the ripple effects of that issue of insurability?
That has been slower to happen than I thought it might. Like, I mean, for me, it bothers me that we're talking about this as an insurance problem because I see it as a lending and a mortgage problem as well. Insurance underpins lines of credit. You have to have insurance to get the mortgage. We haven't really been probably checking whether you have the insurance every year to keep the mortgage. But given that a mortgage is a 30-year product, whereas insurance is a 1-year product, you can see there's a disparity already. I buy a house in good faith. I have a 30-year mortgage on it. For 3 years, my insurance is fine. In year 4, catastrophes around the world have gone up. I also happen to be the one, on the edge of the bowl, for example. And all of a sudden, this is an uninsurable property, but I still got 25 years of mortgage on it. So this thing is starting to happen. Some reports are suggesting now there's about 5% of households where this is starting to be seen as a problem in the mortgage industry, but I would imagine it is more. The other thing that does bother me about this is when we get pretty much total write-off of houses or major damage. So like in a fire where a house could get fully burnt down, you'll see that you get your payment from your insurance company, but maybe 50% or 70% or whatever is the equity still owed that you don't have in that property. goes to the bank to repay the mortgage because they no longer have the asset, rather than goes to you to help you rebuild, which is what insurance is for. So for me, I sort of see us getting into this perfect storm where people who might have insurance, even then, if they also have a mortgage, will be in a situation where they can't use that insurance money necessary to rebuild because it's got to go towards supporting the mortgage. So, we really need to join these finance systems together because insurance doesn't sit out there all on its own.
What are some of the things that that the industry is looking at in terms of responding to this increased climate risk?
Well, I can only speak to what I can observe the industry doing. But what we have observed, and we've observed this for some time, is they're putting up price. Okay, so that is a dominant thing, and this insurance industry is one of the first to say price is a signal. So by putting up price, we're saying this is a high risk or therefore exposed area to build. So price in itself is the dominant signal they have been using for some years now. Over and above that, they are increasingly lobbying governments to do more resilience measures and things like that. They have begun to become somewhat involved in more resilient building. So, for example, in the UK, working through the government reinsurance pool, then insurers can use some extra money that comes from the government reinsurance pool to rebuild by building back better. So that if you're rebuilding a place, you can build it back better. So a little bit of extra money to make it a little bit more resilient. So they are doing those kind of things. I'm aware that in Australia, they've worked with the Resilient Building Council on some bushfire measures people can take. And if you take those measures, that can lower your insurance premium. So they're doing these kinds of things, I would say. I'd like to see more joined upness between insurance, its ability to signal price, its ability to understand risk, and how we plug that into the wider resilience ecosystem, though. I mean, they don't actually have very many levers to change where and how we build. They don't approve planning, and they don't create construction standards. So I'd actually like to see some of that risk analysis and the data plugged into how we manage resilience.
Yes, I'm interested to know whether the insurance industry can leverage its influence and its kind of relationship with government to push for those things. Is that happening? Do you think a little bit?
So I think that, we do have a hazard insurance partnership here now. That is some form of collaboration between government and the insurance industry to try and work out what they're going to do. Certainly the insurance industry put out a call for significant and sustained resilience funding and things like that, and for more land use. So I think that they are doing that. I think that probably they've started to come to that in the last few years. I would say before that they were probably more like, well, we're a market, our job is pricing, and the price is the signal, and people will work that out for themselves. But what we all know is price is actually a very weak signal. If price was a great signal, people wouldn't be living in California. It's on an earthquake zone. So why are they all there if price was such a good signal? Because I can tell you, earthquake insurance California is very underinsured for earthquakes, so because it's so expensive. So if price was a good signal, they wouldn't live there. We already know that price isn't a great signal because people live in houses live in places for many complex reasons. I do think they've stepped up way more than that now with their lobbying and things, but I would actually like to say we should all be advocating for that. I mean, they're just a market. They offer a product, you buy it or you don't. I mean, it's good that they're doing something to make that market sound by lobbying for this, but why aren't I lobbying for this? Why isn't our government lobbying for this? I know we need affordable housing, but how is it affordable to say, here is housing that will be for lower socioeconomic people? It's built in a place that will flood. It's built in a place that will burn. Right. So we'll get those people just going with a mortgage. They'll just have a little bit of equity, and then the place will flood or burn. They won't have had insurance, or they won't get it again. We have not fixed the housing crisis. We have not fixed the inequality and inequity crisis. We've made it worse. So we need to step up with joined up government, not just saying to the insurance sector, you got it wrong, you fix it. We all need to ask our government, how are you going to join the pieces? Because you do actually own the levers of land use planning, construction, and indeed insurance. You can intervene in a market.
If I was your fairy godmother and I said, Paula, you have one wish to be granted, in relation to this twin issue of insurance and climate change. So you got one wish, whether that's a policy issue or a commercial issue. What would be the one thing that, if you had the power to enact, that you would enact?
An open, honest, and willing dialogue between the stakeholders, which is the insurance sector, the three layers of government, and the building and construction industry, and the homeowners. Yeah. Open, honest dialogue that is willing to accept that we are in a changed world and we must live differently.
Things like average neighbours' energy ratings over time. If you look at the evolution of the Green Star rating scheme over time, if you look at the uptake of renewable energy over time, that those are all evidence points that we've gotten a lot better, right? And you look at the new technology that's come to market, but then also become affordable to get into buildings over time. And they're all really clear evidence points that over the last 2.5 decades, that we have gotten a lot better at understanding it, but also delivering on it, and finding ways to do it cost effectively. And that's not just engineering, it's not just architecture, it's not just technology, it's not just suppliers, it's not just advocacy bodies, it's all of that working together. So if that's kind of a view on, I don't see it slowing down, even though there might be in those areas technological and economic barriers. I think that it's only increased since I've been in the industry.
Well, you quite rightly say that it's technological and economic, and as my understanding is that one of the big issues with green hydrogen is the cost of energy, and in a way you could say that cost of energy is a political choice, like the degree to which energy is regulated and how it's regulated, and how much is sent overseas versus domestically, that could change quite radically depending on government policy. And so it seems to me that if the price was different for energy, then all of a sudden it become possible. And
it is interesting, right? Because it's the same conversation at a different scale and with a different subject matter that we had when we had some developers, some investor representatives, the City of Melbourne and the State of Victoria. And the room was full, right? And we had lots of audience participation. It was off the back of that research piece. But it came down to a stalemate between invest in the research to come and tell us what you want so private sector, come to us, public sector, go and invest in the research and tell us what you need, versus, and we're happy to make changes, right? Versus, well, why should we take the risk? Why don't you change the policy, and change the policy, tax reform, regulation, and we'll come and invest here.
Yeah. So kind of classic supplier demand in a way.
Absolutely. It was opposing magnets. That's what
maybe we just back up a little bit and talk about that work that Ingrid Bakker kind of led. So could give us a quick overview of that work in terms of the research that was involved and what was the objective?
Sure. So in the midst of obviously there was a lot of headlines around housing crisis, housing supply issues, in particular in the state of Victoria, in the media. Absolutely there is. As well as issues around carbon, environment, and then the nexus of those two. So how do we increase housing demand while also getting to zero? And at the same time, the occupancy rates in Melbourne were quite low. Right, so there wasn't a lot of people in the city. Tenancy rates were very low. So Ingrid led a piece of work. She looks after our commercial workplace sector. Did a joint piece of work with our residential sector leader to think about, well, what if we had a look at all of the unoccupied buildings in the Melbourne CBD, and looked at what it would take to change those into residential buildings, into housing. To help deliver on some of the state targets. So they got to finding 86 buildings across the Melbourne CBD.
86.
That were built before 1990. There was a different structural integrity, and they were more likely to be being C, D grade buildings that maybe weren't occupied or that needed investment to renovate anyway. So there was already an investment required to get them up to tenancy.
Yep.
Buildings that were at about a 25-metre floor plate, so that you could have 2 apartments.
Double loaded.
Yep.
Yep.
On either side, or an apartment on either side of a corridor. And then buildings that were over 10 stories. So typically they had the structural capacity to take a little bit more load, which meant we could get a bit more yield, which again supports investment.
And that would presumably even be the offer to government, say, give us an extra 6 floors and we'll give you residential.
And that's what came out of it, right? So after that initial piece of research was done, a pilot project was analysed with technical partners and with financial partners, and it very much was the return on investment was below typical hurdle rates. And so there was recommendations and conversation around things like planning regulation and tax reform.
Yeah. So it all sounds very exciting. It sounds like there was a kind of, I guess you'd call it residual land value, or at least the market stacks up to do that. There was and there continues to be considerable vacancy in offices. What's happened? Why didn't government say, this is a great idea, let's proceed and do this?
I would say conversations are still being had.
Right.
But
because this isn't an emergency after all.
Well, that's probably the other reason, right? Is it's still quicker and easier. So there was no technical barriers, but the change in, I don't know if you've ever tried to change a policy. Are they inside an organisation or inside government?
Yeah, right.
Yeah, right. Okay. Yeah. So as this has happened, the housing crises, right, multiple crises of living, have gotten a lot worse. Yeah. And so now a lot of you kind of get the sentiment from a lot of state government mandates now, and what they're saying is just get it done, get it built, get it done. So, like, we came across a lot of issues around structural integrity. That's always really important. Part of what kind of Ingrid found through working with the structural engineering for pre-1990s buildings is that over time there's compaction and you actually get a little bit more strength in the concrete. And they were built to different codes, which is really interesting. Right.
So the classic line that they used to build it better in a way.
Yeah, absolutely. Right. There can be, I guess, timber is used quite a lot to expand existing structures because it's lighter weight to put on top of existing structures. That can come with its own fire issues and regulations. There's heritage they have to think about. There's servicing, particularly if you're changing the use of the building. So yeah, there's lots of bits and pieces that kind of need to be overcome. Yeah. But I think part of what came out of Ingrid's study, and something that we were pushing really hard when I was at Development Victoria, is pulling the problem solving up front. And it's, what we found in all 3 of those projects. So the project I did at Development Victoria and the 2 other projects are clients that were willing to get people around the table early to understand those problems and try and solve them early. So they didn't become roadblocks to the actual project itself. Yeah. Yeah. By going through a normal procurement process.
So why doesn't everyone do that?
Like, we are, as an industry, trained to procure a project a certain way, where we are obsessed with speed at all costs and don't necessarily understand that slowing a project down maybe only means 2 weeks before you go out for your initial consultant procurement, not 3 months. And that can actually save you time at the end. In-house acquisitions teams maybe aren't made up of the right kind of skill sets anymore. Maybe investment committee guidelines need to shift. And I've had a couple of conversations in industry about that happening as well. So the way that we value buildings or value assets. Yeah. And there's all these little bits along the life cycle of the project that we're not incentivized to change. Yep. Right? Or necessarily, I would say, trained to do. Like, it's a different project delivery model, in the same way that if you're going to design, a space or a building with all non-virgin materials, so you're going to source it all not off the shelf, but from recouped places, which is we're doing a couple of those projects at the moment. You got to turn the design process on its head. Right? Yeah. And the first 2 or 3 goes at that is hard and it's exhausting, and you mess up. But once you get it right, kind of you can get into the right swing of things.
Yeah, and also just we are in an architecture office, and it is true that generally speaking, the convention around how architects get paid is as a percentage of the construction value.
Yep.
So you not only are you not incentivized, you're actually incentivized to spend as much. I mean,
As much money.
I'm sure there are ethical architects, but there is a total conflict of interest right there, isn't there? Yeah.
I think so. The whole, it's actually a really interesting research project. Maybe I'll just kind of jump off for a couple of years and go and do that. But there are, just from sitting around the table with so many different hats on, there are so many micro points where something small just could shift, right?
Yeah.
And it would change the answer, not in terms of how much money people make, probably, or the speed at which we could get an outcome, but it would definitely change maybe who the hero was.
Yeah.
But it will also change the outcomes for people and nature at the end for the better.
If I was to give you a wish, if I was your fairy godmother, I say you get to change one policy. What policy would you choose to create better and more sustainable outcomes in buildings?
I would find a way to shift the planning scheme. I think that's where a lot gets held up.
Yep.
At least that's where a lot of the pain point, we hear a lot of the pain point for our clients in terms of being able to, if we could do it quicker, we could do it faster, or if we had more certainty, then we could do that.
Right. Okay. Planning.
Yeah. The other one would be housing, and just getting on with improvements to housing quality. I got to Development Victoria and was told it can't be done. Can't be done. We can't make it better because the volume builders know what they're doing and builders know what they're doing, and it's too expensive. It's too hard, or we're not incentivized. This was before the 7-star NatHERS argument was happening in industry. So I just went, what would it take to get to 7 stars? Right, we'll take a step and then we'll see how much we can go beyond there.
Yeah.
Worked with 4 volume builders that Development Victoria were part of the pool of volume builders that we work with on a regular basis. Used a few projects and a few procurement processes, and we went from 30 grand a house to 10 grand a house to 0 in 3 procurement cycles.
In terms of added cost?
In terms of added benefit for free.
Okay.
So a 7-star going from 6-star to 7-star.
Yeah.
NatHERS, so it is about the thermal efficiency and energy efficiency cost, then cost to run of the home.
Yeah.
But by working with the volume builders and using procurement processes, the initial cost came back at $30,000 a home. The second time we did it, they came back with $10,000 a home, and the third time we did it, it was free.
Wow.
Yes.
Wow. Does that mean those volume builders are going to now deploy?
They have been.
They have.
Yeah.
Right.
So part of their marketing is we can do it.
Right.